All right, today we're going to talk about two-way tables, which is a way of us taking two categorical variables and looking at each other, or looking at them at the same time. It's another categorical display like we talked about yesterday with bar graphs, pie charts, and frequency tables. Now we're just going to kind of take that frequency table and extend it to a second variable. And we're going to talk about how to take those and work with marginal distributions and conditional distributions. So the first thing we talk about is a contingency table or a two-way table. Those are the two terms you'll see used for this type of display. Both are talking about the same thing, just about, or it depends on what book you're looking at. But basically what it does is it shows how individuals of one variable are distributed along each of the others. So in this case, we have two different variables that we're looking at: the class of ticket on the Titanic and whether or not the person survived. So rather than looking at just one variable on its own, we're putting the two variables together. And so basically what we do then is we create a two-way table which looks something like this. So variable 1, and we see the distribution of the categories. So first, second, third, and crew. Variable 2 is survival. We have the separation of the categories, survived versus didn't survive, and so on. And then we just have a complete breakdown in the middle there. And we're going to talk about each of these pieces kind of as we go through the notes today. So the first thing we talk about with these contingency tables is our marginal distributions. And so with the marginal distribution, what that essentially is doing is having us separate the variables. So if it says, what's the marginal distribution of survival, we see highlighted in red here what that marginal distribution looks like. So if I forget class altogether, I don't care about first, second, third class, or crew, I'm just saying, did someone survive or not? I'm then taking that variable of survival and separating it from the other. And so we can see that that's what it looks like. 711 survived, 1,490 didn't. Or, as we looked at yesterday with our bar graph, we talked about the class of individual on the Titanic. And so in that frequency table, we had all of these totals that we see down here at the bottom. So if I wanted to know how many first class passengers, how many second class passengers, and so on, that's what we're looking at there. And so when it says marginal, you're basically picking the variable that they're naming and you're separating it from the other. So you're looking at the column total or the row totals and looking at the breakdown of just that one variable on its own. Another example for a contingency table here, random selection of adults. What do you think the chances are that you will have a much more than middle class income at age 30? The table below shows the responses. And so it asks, in this two-way table, which is a little bit differently set up than the first one, it says, what are the variables described by the two-way table? And so if we look at this closely, we notice that one variable broken down, male versus female, would be gender. So by gender, as we see here, that was one variable that we looked at. The other variable that we looked at is over here, which is basically your opinion about whether or not you'll be rich. So how many people thought they would be rich, depending on whether they're male or female. And so we can use this contingency to kind of look at those relationships. So the first thing we might examine, as we talked about up above, were the marginal distributions. So if we examine the marginal distribution of getting rich, you got to really pay attention to which variable it is we're isolating. And so since I want to know what the marginal distribution for getting rich is, I only care about the responses, the totals, for those answers to whether or not they think they'll be rich. So I'm looking at that row totals over on the side there. Now, again, with marginal distributions, you could leave them in count form. So 194 said almost no chance, 712 said some chance, but probably not. Or you can convert them to percentages. A lot of times, for whatever reason, people deal with percentages a little bit better. So if we break that down, we take each of the individuals, so 194 total said almost no chance out of the 4,826 total people interviewed. And so that gives us a 4% of individuals answered that way. And then some chance, 50-50 chance, good chance, and so on. So we're just calculating each individual percentage based on that overall total. And so then we create this relative frequency table, which is what this is right here. And then we can take that relative frequency table and create a bar graph like we talked about yesterday. So I have my X and Y axis. I have my label. This was the variable that I was in question, the response to the question. We have the percentages along the Y axis, and we we have a title. Always make sure you have those things whenever you're creating a bar graph. Then we notice that we have, starting at 0, even increments of 5%. And then from there, we create our bars for each group. So the people who all answered almost none was about 4%, some chance was almost 15%, and so on. And so by examining that marginal distribution, we can see, okay, regardless of female, male, anything like that, we just want to know how many people thought they would get to a certain point. And so that's what this distribution is going to do. It's going to separate that variable from the other. So that's what it looks like to kind of analyze a marginal distribution, whether it's in counts, whether it's in percents, creating that frequency table, and then a bar graph to accompany it. The other thing, when we look at two-way tables, is that we said we're combining two variables together. And so the table tells us how those two variables interact. So each cell of the table gives us a count for the combination of values of two variables. So as you can see here circled in red, 673 represents the total number of crew members that did not survive the Titanic sinking. Or over here, we see that of the first class passengers, 203 survived. So in the actual table itself, that's a combination of the two variables together. How many of this variable were also part of this? And so that's what those cells in the middle are going to tell you, is the combination of those two. Now, when you're working with contingency tables and you're looking at those combinations, you got to be really careful with how you calculate your percentages. The questions are going to sound very similar, but they are asking different things depending on the wording of the question. So for instance, if we look at the three questions down here, what percent of the survivors were in second class? What percent were second class passengers who survived? What percent of the second class passengers survived? Okay, now all of those look very similar on the surface. So I'm looking at this, it seems like I should be calculating the same thing every time. But if I look closely, this first question says what percent of survivors? And so that's why this question right here, percent of what, becomes such a big thing. So what percent of survivors were in second class? And so as we're looking at that, that means I'm restricting myself to survivors. So I only have 711 total survivors, which means that's the total for my percentage calculation. Now from there, it says how many of them were in second class. Well, for the survivors in second class, there were 118 that fit that bill. So if I was going to calculate the percentage, I would have 118 out of that 711. Now if I go to the second question, it says what percent were second class passengers who survived? Now this one's a little bit different because when I look at this what percent of who, they didn't establish a given condition. They just said what percent. So what percent of individuals were second class passengers who survived? What that tells me then is I'm now looking at the total number of passengers. So when I'm calculating this percentage, my total number of passengers was 2,201. That's my total for my percentage. And then it says what percent were second class who survived. So I still want that same cell, the 118 second class passengers who survived, but now my total changed, which changes my percentage as well. And then if we look at that last one there, it says what percent of second class passengers survived? And again, if we ask percent of what, percent of second class passengers. So now this time I'm only interested in second class passengers, which means my total is out of 285. And then I use the same numerator because I'm still using 118 second class passengers who survived. So even though all three questions looked almost identical, all three yielded a completely different percentage. So you got to be really careful and make sure you ask yourself percent of what in order to calculate that correct percentage there. Now, conditional distributions, these are the ones that are probably a little bit more difficult. And a lot of times it's just a matter of being able to set up the right conditional distribution. And so a conditional distribution shows the distribution of one variable for just the individuals who satisfy some condition for another. So of the two variables, they're going to say, what's the distribution of this variable if or given this condition from the second? So like if we look below here, it says the following conditional distribution of ticket class. So the distribution is about ticket class, condition or given the person survived. And so as we're looking at this,
the bell is about to ring. This will be for teams C and D to go to lunch. Teams A and B, please stay in advisement.
And so as we're looking at this, we're looking at the distribution of class, but we are conditioned upon having survived. So right now, I don't care about the non-survivors in the overall table. I'm looking at just out of survivors. So I had 711 survivors. Of those, 203 were first-class passengers. If I take the 203 divided by the 711, that creates my 28.6%. If I look at my second-class passengers, 118 out of the 711 gives me 16.6%. And so as I'm looking at this distribution, I'm only looking at survivors, and I don't care about any other part of this. So it's how did class distribute itself amongst the survivors? And so, like I said, the hardest part about this is making sure you get the right variable and then the right portion of the condition based on the other one. Now, with these conditional distributions, what they allow us to do is compare and determine if there are associations or relationships between variables. So if I'm going to compare conditional distributions, the first and most important part is selecting the correct rows or columns of interest. So understanding which variable it is we're looking at for the distribution, and then what's the condition on the other one that we have to account for. We use the data in the table to calculate the conditional distribution in percents, just like we did up above. We make a graph of the display, and in this case, we're going to use either a side-by-side bar graph or what we call a segmented bar graph, and I'll try to show you an example of each one. So what we're looking at for these is just a modified version of the bar graph, but we're going to have to kind of build everything to get to that point. So as we look at this next example, it has kind of everything all together here, so we're going to kind of break it down. The first thing it wants us to do is calculate the conditional distribution for the opinion among males. Now here again, we have to pay close attention. The conditional distribution of opinion. So that means I want these column values, but only among males. So the first thing it asks us to do is just evaluate this column. So what did males believe about their economic status by the time they reach age 30? And so that corresponds to this first column here. And so as we're looking at this, there were 98 males that thought almost no chance of being rich out of, and can't see the total down here, but 2,459 total males. And then for some chance, 286 out of the 2,459, and so on. So we're just calculating the conditional distribution for males. And so we were looking at the variable, what their opinion was, and we were only looking at the males. Now the second part of the problem says, examine the relationship between gender and opinion. So now they want to kind of know, is there some sort of relationship between gender and opinion on whether or not they'll be rich? And so as we look at this, we already have the conditional distribution for males. So we already calculated that, which means the only other thing we're going to need to compare is what does it look like for females. So then we take our females and we create a conditional distribution for those as well. So this time we have the 96 females out of the 2,367, and so we create this second conditional distribution. And then once I have my two conditional distributions, I want to know what they look like together. Now, in the segmented bar graph, that's what this graph over here on the right is. In a segmented bar graph, you're going to have your X and your Y axis, just like normal. Now, the variable in question was the opinion. So that's extremely important. We were looking at the distribution of opinion, and we had two different groups. We had males and we had females. So we're going to create the entire graph for males in this particular portion and the entire graph for females there. The y-axis in a segmented bar graph will always be the same. Now you can break down the percentages differently as long as they're equally incremented, but it's always going to be a percent along the y-axis, and it's always going to go from 0% to 100% every time. And then don't forget, with any graphical display, we always have to have a title. Now the way they created this was they started with the males, and they went ahead and started with the almost no chance. So that was the first thing they did, was they marked almost no chance, went up about 4%. And then the some chance added another 11.6%, so that moved up to 15.6%. And then from there, they added in the 29.3 for 50-50, and they just kind of kept building their graph, adding the percentages over and over until they get to the final, which should reach 100%. And then the same thing for females. As you're looking at females, they started with almost no chance, so 4% there. Then they added in the 18% for the some chance, and then they added in the 29.4 for the 50-50 chance, and so on, and they built all the way up to 100%. Okay? And so as you're making that segmented bar graph, that's exactly what you're looking at. Now from there, what you're going to be doing then is you're going to be using those graphs to look for an association. So we're going to scroll down here real quick, and then we'll go back up and take a look at that. It says there's an association between two variables if knowing the value of one helps predict the value of the other. Basically, if there are differences in the conditional distribution, it means that there is some sort of association. If I know it's male, I know they're more likely to do something or less likely to do something than females are. Or if the conditional distributions are almost identical, then it doesn't matter which gender I pick, the opinion's going to be about the same no matter what. And so if we go back to our graph here and we look, we notice that, and you can look at the percentages over here, or you can look at the segmented bar graph if you want to, but what kind of sticks out here is we notice that females were more likely to answer some chance of being rich as opposed to the males who were less likely to do so, 18% versus 11.6%. Also then, if we kind of examine a little more closely, we notice that males were much more likely to answer almost certain versus females. And so this is one of those things where, because we see those kind of big differences between the two, we would say that males are more likely to say almost certain and less likely to say some chance, versus females who would be less likely to say almost certain but more likely to say some chance. And so we see that there's a difference in a couple of those different groups, which means there is some sort of association. Even though some of the groups were almost the same, like 4% and 4.1, 29.3 and 29.4, because there were differences anywhere within the graph, that tells us that there is some sort of association. And so that's kind of what we're looking for. Now, this was a segmented bar graph. The other thing you can also create, and I'll kind of do it on this slide down here a little bit, is what we call a side-by-side bar graph, where we have, in this case, we're looking at the opinion of the individuals. We have our percentages along the side here. Now, this isn't going to be from 0 to 100% anymore. It's going to be 0 to whatever our largest percent is, which in this case was, looks like 30.8%. So we want to make sure that we have something that goes up to maybe like 35%. Okay, so I'm not going to create the whole thing right now. But basically what you would do is you would start with the first category we started with was almost no chance. So for almost no chance, I'll just abbreviate here, we had our males, which were at about 4%, and we had our females, which were about 4%, and you just put the bars side by side. Then you go to your next category, which was some chance, and again, I'll kind of abbreviate, and so the males were like 11.6%, but the females were like 18%. And so that's where we see that big difference there. And then I continue on and make the side-by-side bars all the way across. So for each category, I look at both male and female right together side by side. Then I go to the next category, male and female or side by side, and so on. And so that's a side-by-side bar graph, remembering labels, and I didn't put a title, but you would want to make sure there's a title there. But that's what that's going to look like too, and you should get some practice with a little bit of both. Now, of the two types, this is probably the segmented bar graph is probably the one most likely to be used, so that's one that you probably want to get more familiar with. But that's kind of what we do when we talk about comparing the distributions. We want to know if there's some association between the two things. So from there, you should be able to do the homework, go through and look at some of those examples. They should pertain to a lot of what we discussed here. If you have questions, make sure you ask in class. Make sure you're checking Google Classroom and kind of getting those things figured out from there.